This tutorial will guide you through the process of creating a volume mesh for a cast part. You will learn how to apply global and local mesh parameters using mesh controls. Finally, you will export the solver deck and a mesh specification with all parameters. Start by importing your CAD file. You can simply drag and drop it into the graphics area. Turn on the group option if you plan to automate the assignment of mesh controls. Determine the size of your model using the Measure tool. You can also select an edge on your body to read its length in the output window. Create a body mesh control to apply the global mesh parameters. The TET10 curved edge option creates second-order elements. Enter a target element size of 7 mm. When meshing, SimLab will automatically suppress all small geometry edges to achieve the desired minimum element size. The local refinement for curved faces, such as holes and fillets, is defined in the geometry approximation section. In this case, for example, an angle of 30 degrees will result in 12 elements around the small holes. The fillet selection filter makes it easy to select the fillets that require a finer mesh. We define a fillet mesh control to obtain 3 rows of elements on the selected faces. Remember that the mesh definition for generic fillets is already controlled in the body mesh control under geometry approximation. You can use the fillet mesh control to define additional mesh refinement on selected faces, like in this case. Face mesh controls can be used to define a minimum number of shell elements by thin faces. Please note that this does not directly affect the number of TET elements inside the volume and that we will need an additional mesh control if we want volume layers inside. A cylinder mesh control defines the element size or the number of elements for a cylindrical surface, both in the circular and axial directions. Note that if you need to select a large number of cylinders, you can use the Select Identical Faces function. You can also use the Select Features right-click option to select cylindrical faces or even holes based on size and shape. A region mesh control can be applied to the body to specify a mesh refinement in a particular region. In this case, we choose to refine the mesh in the region inside the cylinder. The break option can optionally be enabled if the body also needs to be cut. All mesh controls are listed in the Mesh Control browser. Enable the visualization in the right-click menu if you want to display the coloring of mesh controls. Since the meshing algorithm is allowed to suppress geometry edges in order to achieve the minimum element size, in some cases it can be useful to explicitly preserve the entities that should not be modified. In this case, we preserve the planar shape of the faces on which we want to define a contact. You can always double-click on a mesh control in the browser to edit it, for example by adding entities or changing the values entered. Although you could create a solid mesh directly, for more complex parts it may be useful to create a surface mesh first. As we have already defined the mesh size in the mesh controls, the values entered in this panel will not affect the mesh. When creating a mesh for structural analysis, it is recommended that you enable the option, Identify Features and Mesh on CAD bodies. This will mesh the body using rectangular triangles where possible and give a typical mesh structure on features, such as fillets, with a sensible reduction in the number of nodes. Disabling this option will result in a mesh based on equilateral triangles, with a higher element quality but also a higher number of nodes. The Volume Layer Mesh control allows you to specify the minimum number of layers of TET elements on thin bodies or regions of them. When creating the volume mesh, you can specify the most relevant quality criteria to be achieved. The cutting plane option allows you to look inside the body, for example, to check that the element layers have been created as required. The mesh is finally listed in the browser as a solid FE body. In the browser you can also check the details about the number of nodes and elements. Export the elements in your preferred solver format, for example OptiStruct. Select the unit system you wish to use. You can save the mesh settings to an XML text file. This mesh specification can also include information such as face colors or group names for automatic reassignment of mesh controls to entities.